datetime.tzinfo objects. Class datetime.tzinfo. This is an abstract based class, meaning that this class should not be instantiated directly. Define a subclass of tzinfo to capture information about a particular time zone. An instance of a concrete subclass of tzinfo can be passed to the constructors for date type and time objects. The later objects view their attributes as being in local time, and the tzinfo object supports methods revealing offset of local time from UTC, the name of the time zone, and the DST offset, all retrieve to a date or time object passed to them. You need to derive a concrete subclass and at least supply implementations of the standard tzinfo methods needed by the datetime methods you use. The datetime module provides time zone, a simple concrete subclass of tzinfo which can represent time zones with fixed offset from UTC, such as UTC itself or North American EST and EDT. Special requirements for pickling. A tzinfo subclass must have an integer method that can be called with no arguments, otherwise it can be pickled but possibly not unpickled again. This is a technical requirement that may be relaxed in future. A concrete subclass of tzinfo may need to implement the following methods. Exactly which methods are needed depends on the uses made of aware datetime objects. If in doubt, simply implement all of them. tzinfo.utc UTC offset, return offset of local time from UTC as a time delta object that is positive east of UTC. If local time is west of UTC, this should be negative. This represents the total offset from UTC. For example, if a tzinfo object represents both time zone and DST adjustment, UTC offset should return their sum. If the UTC offset is not known, return none, as the value returned must be a time delta object strictly between time delta hours is equal to 24 and time delta hours is equal to 24. The magnitude of the offset must be less than 1 day. Most implementations of UTC offset will probably look like one of these. Return constant, fixed offset class, return of constant plus self.dst daylight aware class. If UTC offset does not return none, DST should not return none either. The default implementation of UTC offset raises not implemented error. tzinfo.dst return the daylight saving time adjustment as a time delta object or none if DST information is not known. Return time delta 0 if DST is not in effect. If DST is in effect, return the offset as a time delta offset. See UTC offset for details. Note that DST offset, if applicable, has already been added to the UTC offset returned by UTC offset. So there is no need to consult DST unless you are interested in obtaining DST info separately. For example, datetime.timetable calls its tzinfo attributes DST method to determine how the tm underscore is DST flag should be set, and tzinfo.from UTC calls DST to account for DST changes when crossing time zones. An instance TZ of a tzinfo subclass that models both standard and daylight times must be consistent in this sense. tz.utc offset dt minus tz.tst dt must return the same result for every datetime dt with dt.tzinfo is equal to tz. For sen tzinfo subclasses, this expression yields the time zone's standard offset, which should not depend on the date or time but only on geographic location. The implementation of datetime.as as time zone relies on this but cannot detect violations. It is the programmer's responsibility to ensure it. If a tzinfo subclass cannot guarantee this, it can be able to override the default implementation of dzinfo.from UTC to work correctly with as time zone regardless. Most implementations of DST will probably look like one of these. DST self DT, a fixed offset class, doesn't account for DST, return time delta 0. Or DST self DT, code to set DST on and on DST off to the time zones DST transition times based on the input dt.year and expressed in standard local time. If DST on less than equal to dt dot, replace tzinfo is equal to none less than DST off. Return time delta hours is equal to 1, else return time delta 0. tzinfo.tzname dt. Return the time zone name corresponding to the datetime object dt as a string. Nothing about string names is defined by the datetime module, and there is no requirement that it mean anything in particular. For example, GMT UTC minus 500 minus 5 colon 00 EDT US slash Eastern America slash New York are all valid replies. Return none if a string name is not known. Note that this is a method rather than a fixed string primarily because some tzinfo subclasses will wish to return different names depending on the specific value of dt passed, especially if the tzinfo class is accounting for daylight time. The default implementation of tzName range is not implemented error. These methods are called by a datetime or time object in response to their methods of the same names. A datetime object passes itself as an argument and a time object passes none as the argument. That a tzinfo subclass method should therefore be prepared to accept a dt argument of none or of class datetime. When none is passed, it is up to the class designer to decide the best response. For example, returning none is appropriate if the class wishes to say that time objects don't participate in the tzinfo protocols. It may be more useful for UTC offset none to return the standard UTC offset, as there is no other convention for discovering the standard offset. When a datetime object is passed in response to a datetime method, dt.tzinfo is the same object as self. Tzinfo methods can rely on this unless user code calls tzinfo methods directly. The intent is that the tzinfo methods interpret dt as being in local time and not need worry about objects in other time zones. There is one more tzinfo method that a subclass may wish to override. tzinfo.fromUtcDT. This is called from the default. This is called from the default datetime.as time zone implementation. When called from that, dt.tzinfo is self and dt's date and time data are to be viewed as expressing a UTC time. The purpose of from UTC method is to adjust the date and time data, returning an equivalent date time in self's local time. Most tzinfo subclasses should be able to inherit the default from UTC method implementation without problems. It is strong enough to handle fixed and offset time zones and time zones accounting for both standard and daylight time, and the later even if the DST transition times differ in different years. An example of a time zone the default from UTC method implementation may not handle correctly in all cases is one where the standard offset from UTC depends on the specific date and time passed, which can happen for political reasons. The default implementations of as time zone method and from UTC method may not produce the result you want if the result is one of the hours straddling the moment the standard offset changes. Skipping code for error cases, the default from UTC implementation acts like the following. Diff from UTC self dt raise value error if dt.tzinfo is not self dt off is equal to dt.utc offset method. dt dst is equal to dt dot dst method. Raise value error if dt off is none or dt dst is none. Delta is equal to dt off minus dt dst. This is self standard offset. If delta dt plus is equal to delta, convert to standard local time. Dt dst is equal to dt dst. Raise value error if dt dst is none. If dt dst, return dt plus dt dst, else return dt. In the following tzinfo underscore examples dot py file, there are some examples of tzinfo classes. Let's copy the program. Okay, till here. Time example 2. Paste all program. Now from date time import tzinfo time delta date time. 0 is equal to time delta 0. Hour is equal to time delta hours is equal to 1. Second is equal to time delta seconds is equal to 1. A class capturing the platform's ideal idea of local time may result in wrong values on historical times in time zones where UTC offset and or the DST values are had changed in the past. Import time as underscore time. STD offset time delta seconds is equal to underscore hyphen underscore time dot time zone. If underscore time dot daylight dt offset is equal to time delta seconds is equal to minus underscore time zone dot alt zone, else dt offset is equal to std offset. Dt offset is equal to dst offset minus std offset. Class local time zone tzinfo. Diff from UTC self dt. Assert dt dot tzinfo is self. Dt.tzinfo is self. Stamp is equal to dt minus date time 1971 1 tzinfo is equal to self slash slash second. Args underscore time dot local time stamp colon 6. dst underscore diff is equal to dst diff slash slash second. Detect fold is equal to args is equal to underscore time dot local time stamp minus dst difference. Return date time pointer hours microsecond is equal to dt dot microsecond. Tzinfo is equal to self fold is equal to fold. Deep UTC offset self dt. If self dot underscore is dst dt, return dts dst offset, else return std offset. Diff dst dt. If self dot underscore is dst dt, return dst diff, else return 0. Diff tz name self dt. Return underscore time dot tz name self dot underscore is dst dt. Diff underscore is dst self dt. Dt is equal to dt dot year comma dt dot month comma dt dot day dt dot hour dt dot minute dt dot second dt dot weekday 00. Stamp is equal to underscore time dot mk time tt. Tt is equal to underscore time dot local time stamp. Return tt dot tm underscore is dst greater than 0. Local is equal to local time zone. A complete implementation of current DST rules for major US time zones. Diff first underscore Sunday underscore on or after DT. Days to go is equal to D6 minus DT dot weekday. If days dot to go, DT plus is equal to time delta days to go. Return DT. US DST rules. This is a simplified, for example, wrong for a few cases, set of rules for US DST start and end times. For a complete and up-to-date set of DST rules and time zone definitions, visit the Olson database or try PyDZ. In the US since 2007, DST starts at 2 a.m. standard time on the second Sunday in March. which is the first Sunday on or after March 8. DST start underscore 2007, date time 1382, and ends at 2 am DST time on the first Sunday of November. DST and underscore 2007 is equal to date time 11112. From 1987 to 2006, DST used to start at 2 am Standard Time on the first Sunday in April and to end at 2 am DST time on the last Sunday of October, which is the first Sunday on or after October 25. DST star underscore 1987 underscore 2006 is equal to date time 1412. DST and 1987 2006 is equal to date time 110 22. From 1967 to 1986, DST used to start at 2 am Standard Time on the last Sunday in April, the one on and after April 24, and to end 2 am DST time on the last Sunday of October, which is the first Sunday on or after October 25. DST start 1967 underscore 1986 equal to date time 1424 to DST and 1960 to 1986 DST and 1987 2006. Diff USD DST range year. First start and end times for US DST for years before 1967. Return start is equal to end for no DST. If 2006 less than year, DST start DST end is equal to DST start underscore 2007 comma DST end underscore 2007. Else if 1986 less than year less than 2007, DST start DST end is equal to DST start underscore 1987 2006 comma DST end 1987 2006. Else if 1966 less than year less than 1987, DST start comma DST end is equal to DST start 1967 1986 DST end 1967 1986. Else return date time year 1 comma blank pointer 2 multiply by 2. Start is equal to first Sunday on or after DST start dot replace year is equal to year, and first Sunday on or after DST end dot replace year is equal to year. Return start and class UST US time zone TZinfo init self hours wrapper name STD name DST name. Self dot std offset is equal to time delta hours is equal to hours. Self dot wrap r name is equal to wrap r name. Self dot std name std name. Self dot dst name dst name. Diff underscore underscore wrap r underscore self return self dot wrap r name, and diff tz name self dt. If self dot dst dt return self dot dst name, else return self dot std name. Diff UTC offset self dt return self dot std offset plus self dot dst dt. Diff dst self dt. If dt is none or dt dot tzinfo is none, an exception may be sensible here. In one or both cases, it depends on how you want to treat them. The default from UTC implementation called by the default as time zone implementation passes a date time with dt.tzinfo is self return 0. Assert dt.tzinfo is self start comma end is equal to US DST range dt.year. Can't compare nav to aware objects, so strip the time zone from dt first. Dt is equal to dt dot replace tzinfo is equal to none. If start plus hour less than equal to dt is less and dt less than end minus hour, dst is in offset return hour. If end minus hour less than equal to dt less than end, fold an ambiguous hour, use dt dot fold to disambiguate. Return 0 if dt dot fold. If dt dot fold, return 0 else hour. If start less than equal to dt less than start plus hour gap a non-existent hour, reverse the fold rule. Return if dt dot fold return hour, else 0. DST is off, return 0. Diff from UTC self DT. Assert DT dot times tzinfo is self start comma end is equal to US DST range DT dot year. Start is equal to start dot replace tzinfo is equal to self. End is equal to end dot replace tzinfo is equal to self. STD time is equal to DT plus self dot STD offset. DST time is equal to STD time plus hour. If and less than equal to DST time less than and plus hour. Repeated hour. Return STD time dot replace fold is equal to 1. If STD time less than start or DST time less than greater than equal to end. Standard time. Return STD time. If start less than equal to STD time less than end minus hour daylight saving time, return DST time. Eastern is equal to US time zone minus 5 Eastern EST EDT. Central is equal to US time zone minus 6 Central CST CDT. Mountain UST time zone minus 7 Mountain MST MDT. Pacific UST time zone minus 8 Pacific PSTT. Note that there are unavoidable subtleties twice per year in a tzinfo subclass accounting for both standard and daylight time. At the DST transition points, for concreteness, consider US Eastern UTC minus 0500 where EDT begins the minute after 1 colon 59 EST on the second Sunday in March and ends the minutes after 1:59 EDT on the first Sunday in November. When DST starts the start line, the local wall clock leaps from 1:59 to 3. A wall time of the form 2 mm doesn't really make sense on that day. So, as time zone EST won't deliver a result with hours is equal to 2 on the day DST begins. For example, at the spring forward transition of 2016, we get from datetime import this from tzinfo examples import our eastern u0 is equal to datetime 2016 3:13:5 tzinfo is equal to times out dot ugt for I in range 4 u is equal to u0 plus I into our t is equal to u dot s times on eastern print u dot time UTC is equal to blank t dot time t dot tz name. When DST ends the end line, there is potentially worse problem. There is an hour that can't be spelled unambiguously in local world time. The last hour of daylight time in Eastern, that is times of the form 5 UTC on the day daylight time ends. The local wall clock leaps from 1:59 daylight time back to 1 standard time again. Local times of the form 1 colon are ambiguous as time zone mimics the local clock's behavior by mapping two adjacent UTC hours into the same local hour. Then, in the Eastern example, UTC times of the form 5 colon and 6 colon both map to 1 colon when converted to Eastern, but earlier times have the fold attribute set to 0 and the later times have it set to 1. For example, at the fallback transition of 2016, we get u0 is equal to dead time 2016 11:6. Tzinfo is equal to time zone dot utc for I in range 4. U is equal to u0 plus I into hour. T is equal to u dot s time zone eastern print u dot time utc is equal to t dot time t dot tz name t dot fold. This. Note that the datetime instances that differ only by value of the fold attribute are considered equal in comparison. Applications that can't bear wall time ambiguities should explicitly check the value of the fold attribute or avoid using hybrid tzinfo subclasses. There are no ambiguities when using time zone or any other fixed offset tzinfo subclass, such as a class representing only EST, fixed offset minus 5 hours, or only EDT fixed offset minus 4 hours. Zone info. The date time module has a basic time zone class for handling arbitrary fixed offset from UTC and its time zone.utc attribute, a UTC time zone instance. Zone info brings the IANA time zone database, also known as the Olson database, to Python, and its usage is recommended. IANA time zone database. The time zone database, often called TZ data or zone info, contains code and data that represent the history of local time for many representative locations around the globe. It is updated periodically to reflect changes made by political bodies to time zone boundaries, UTC offsets and daylight saving rules. Thank you.